Last week, before the ACT, we reviewed a little bit of trigonometry. Trigonometry literally means triangle measurement in Greek. That's where all of these concepts originated, was in ancient Greece. We have three main trigonometric ratios. We're going to learn three others later in this unit, not today. First one is sine, which literally is the ratio of the length of the side opposite an angle in a right triangle divided by the length of the hypotenuse in that same triangle. Cosine is the ratio of the length of the side adjacent to the angle over the hypotenuse. And tangent is the ratio of the length of the side opposite the angle over the leg adjacent to the angle. In summary, we have this little detail right here, and we talked about the term or the mnemonic device SOHCAHTOA last week to remember sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And I've drawn a triangle to help you see how this side is opposite to the angle, this leg is adjacent to the angle, and the hypotenuse is always across from the right angle. If we were referring to this angle instead, down in this corner of the triangle, then the opposite side would be here and the adjacent side would be here. They would just trade places. That does happen sometimes, so you have to pay attention to where the angle is that you're working with to know which leg is adjacent and which leg is opposite. With that in mind, let's talk about a few other things that you can actually see in your workbooks on page 390. First thing it talks about on page 390 is the unit circle. The unit circle is a name for a circle on a coordinate graph, so an XY rectangular coordinate system, and that circle has a radius of 1. When we think about the radius in a circle as compared to an XY graph, it ends up being the hypotenuse of a triangle with sides x and y. The cosine of the angle is the x-coordinate where the terminal side of the angle intersects with the unit circle. The sine of theta is the y-coordinate of the point where the angle terminal side intersects the unit circle. Let's see why that information is true. Let's go to some problems in our workbook on page 390. That's not quite what I want to get to yet. Let's look at something else first. Alright. Let's just draw a triangle in the first quadrant. And let's suppose that this triangle is drawn within the unit circle, and that point right there has an x value of square root of 3 over 2 and a y value of 1/2. That's because the radius is 1, and I've chosen a triangle that has a 30-degree angle. The fact that this point right there is an x value of square root of 3 over 2 and a y value of 1/2 means that this side of our triangle here has a distance, a length, of the number square root of 3 over 2, which is like, I don't remember, it's a decimal answer, 1 point something. And then this y value has a distance, this side of our triangle has a length of 1/2. That's our y value. This is our x value. Now let's think about sine and cosine. Sine of 30 would be the opposite leg over the hypotenuse. The opposite leg happens to be 1/2, and the hypotenuse happens to be 1 because this is the unit circle. Well, if you try to divide 1/2 by 1, you just keep with the answer 1/2. So the sine of 30 degrees is 1/2. Which is actually the y-coordinate of that point where the angle meets the unit circle. Likewise, the cosine of 30 is adjacent over hypotenuse. So the adjacent leg is a length of square root of 3 over 2, and then the hypotenuse is 1. Anytime we divide by 1, we just keep that same number. So the cosine of 30 degrees is the square root of 3 over 2. Notice how square root of 3 over 2 is the x-coordinate. So for this assignment, you are simply going to give the y-coordinate for the sine value and the x-coordinate for the cosine value. Now let's go over some other angles that are a little bit stranger than that. Let's start with this one, negative 90 degrees. Again, I'm on page 390 in your workbook. Negative 90 degrees is going down this direction. We start here and then we go clockwise to here. Now let's imagine that this terminal side is intersecting the unit circle. The unit circle has a radius of 1. So what is that point right there on our xy graph? Well, that point is located at 0 because we don't move left or right at all. Negative 1 because we have to go down 1 to get to that point. So 0, negative 1. Remember how cosine is the x value and sine is the y value. So the cosine of negative 90 is the x value 0, and the sine of negative 90 is the y value negative 1. Let's do the same thing with 360 degrees. That means we start here, we go all the way around, and the terminal side is right on top of the initial side. Imagine that this is intersecting our unit circle, which has radius 1. So where is that point located on our graph? The x value is 1 and the y value is 0. Since cosine equals 1, or equals the x value, and the x value is 1, the cosine of 360 is 1. Since sine is the y value, the sine of 360 is 0, because that's the y value. Since 360 is also 0 degrees, that means the cosine of 0 is 1 and the sine of 0 is 0. Check those with your calculator if you would like to. Alright, now 540 degrees. First thing we want to do is figure out which angle that's coterminal with. So let's take 540 and subtract 360. Gives us 180. I couldn't do it on my head. That must mean it's at the end of the day after a long week. So 180 degrees is the terminal side of the angle going this way that started this way. Now, of course, again, we need to imagine it intersecting the unit circle right there. Unit circle has a radius of 1. So that point right there at the 180 degree mark will be at negative 1, 0. Cosine is the x value, so cosine of 180 or of 540, it's the same either way, will be the x value negative 1, and the sine of 180 or 540 will be 0. Do the same thing with these two problems here. Why don't you try those for me? Now we're going to apply this stuff to special right triangles that we were just talking about earlier. I think I'll go ahead and go through these with you. I know these videos are rough, aren't they? So negative 270 would be here at 90 degrees. So intersecting the unit circle would put that point at 0, 1. So the cosine of 90 degrees at 0, 1 would be the x value, 0. And the sine of 90 degrees at 0, 1 would be 1. Well, that's not what it asked us for. It asked us for the cosine of negative 270 and the sine of negative 270. But since those are coterminal with 90 degrees, those are the exact same answers. When we start to graph these, not on this type of graph, but on an actual graph where we're comparing the angle to the ratio, we're going to end up with a graph that's periodic, that repeats over and over and over, because the values repeat every time we go around the circle. This one is a way big number. Let's subtract 360 to find its coterminal answer. And I'm going to subtract 360 again, which gives me 0 degrees. I already did this one earlier today, in this video, in fact. So sine of 0 is 0, and cosine of 0 is 1. You'll want to start memorizing these, because then it will make things that we're doing in the rest of the chapter be easier. So see how that point right there at 0 degrees is 1, 0, and cosine is the x value and sine is the y value.